we shall solve a very interesting algebraic problem. Here problem is that how many pairs of positive integers mn are there satisfying an equation which is m cube minus n cube is equal to 21. We have to find out the positive integer pairs mn which satisfies an equation m cube minus n cube is equal to 21. Now, let us start. Here equation is given as this. This is an equation of cube. This is an cubic equation in mn. M cube minus n cube is equal to 21. We can factorize both sides of this equation. Factorizing the left hand side, we get m minus n. This is the formula a cube minus b cube. This formula is as this mn plus n square. That is a cube minus b cube is equal to a minus b, a square plus ab plus b square. This is the algebraic formula. In this way, we have factorized the left hand side of this equation. Now, we shall factorize also the right hand side of this equation. Right hand side is a number which is 21. Factors of 21 are 1, 3, 7 and 21. So, reduced into factors, we shall 21 reduced 21 into factors as this, that is 1 multiplied by 21, 21 multiplied by 1, 3 multiplied by 7, 7 multiplied by 3. In these 4 ways, we can factorize 21. This is. Now, here also m minus n is strictly less than m square plus mn plus n square. For mn belongs to the set of positive integers. Set of positive integers. Mn are positive integers. So, we can say that m minus n always strictly less than m square plus mn plus n square. Now, we can equate left hand side with right hand side. Here m minus, we can choose m minus n is equal to 1 and m square plus mn plus n square is equal to 21. And also we can choose m minus n is equal to 3 m square plus mn plus n square is equal to 7. We have chosen as this because m minus n is less than m square plus mn plus n square. So, if we choose m minus n equal to 1, then obviously m square plus mn plus n square is equal to 21, also 1 less than 21. And here also we have chosen m minus n as 3 and this as 7 because 3 less than 7. So, we can express m in terms of n from this equation. We can express m in terms of n. In this equation, we can express m in terms of n, and this is m equal to n plus 1. M is equal to n plus 1. And also we can put m is equal to n plus 1 in this equation. After putting this relation in this equation, we get m is equal to n plus 1, that is n plus 1 square. N plus 1 multiplied by n plus n square is equal to 21. So, n square plus 2n plus 1 plus n square plus n square is equal to 21. So, we get 3n square plus 3n plus 1 is equal to 21 is equal to 21. So, 3n square plus 3n minus 20 is equal to 0. 3n square plus 2n plus n is equal to 3n, n square plus n square plus n square is equal to 3n square plus 1 is equal to 21. So, 3n square plus 3n minus 20 is equal to 0. Also we can use Siddharacharya's rule for the solution of this equation. This is a quadratic equation of n. So, applying Siddharacharya's rule, we get n is equal to minus 3 plus minus root over of b square minus b is here plus 3. So, minus b minus 3 plus minus b square is 3 square 9 minus 4ac 4 into 3 into c means minus 20, that is 4 multiplied by 3 multiplied by minus 20 over 2 into 3, 2 into a. So, minus 3 plus minus 9 plus 4 multiplied by 3 multiplied by minus 20 is 240 minus plus 240 plus 9 plus minus root over of 249 over 6, this is 6. N is equal to this, but square root of 249 cannot be a perfect square. Square root of 249, that is 249, cannot be a perfect square, but 249 is not a perfect square. Perfect square. So, we are not able to rationalize this radical. We cannot be able to rationalize this quantity because 249 is not a perfect square. If this is a perfect square, we can easily rationalize this term, but we cannot rationalize this term because 249 is not a perfect square. So, n cannot be an integer. So, here value of n is non-integer, also non-rational, also obviously non-rational, non-integer, that is non-rational number, because 249 is not a perfect square. So, here value of n is not a integer, is non-integer, that is non-rational number. So, we cannot be able the integer value of n from this equation. We cannot be able to find the integer value of n from this equation. Now, we shall go to the second equation, that is m minus n, second set of equation. Here second set of equation is m minus n is equal to 3 and other is m square plus mn plus n square is equal to 7. Here also we can express m in terms of n from this equation. So, m is equal to n plus 3, m is equal to n plus 3. We can put this value in this equation. So, we get n plus 3 square plus n plus 3 plus n square is equal to 7. Now, we can expand this square. After expanding this square, we get n square plus 6n plus 9 plus n square plus 3n plus n square is equal to 7. We have got this. Now we can get 3n square. After adding this 3n square, we get 3n square. After adding 6n and 3n, we get 9n. And also 9 minus 7. 9 minus 7, that is 9 minus 7 is 2. 9 minus 7 is 2. 9 minus 7 is 2 plus 2, that is equation is 3n square plus 9n. 3n square plus 9n plus 2 equal to 0. Here we can also apply the Sridharacharyya's rule for the solution of this quadratic equation. Now applying this rule, we get n is equal to minus b. Minus b is minus 9 plus minus square root of b square. B square is 9 square, that is 81, minus 4a. A is 3. 4 multiplied by 3 multiplied by c is 2. This is over 2 into a, that is 3. 2 multiplied by 3. We get from this minus 9 plus minus 4 multiplied by 3 multiplied by 2 is 24. 24, that is plus 81 minus 24, that is 57. 57 over 6. This is also a non-integer, or that is non-rational, because 57 is not a perfect square here also, but 57 is not a perfect square. So value of n is non-rational, that is non-integer, because 57 is not a perfect square. As 57 is not a perfect square, this term cannot be rationalized. This term cannot be, root 57 cannot be rationalized, because 57 is not a perfect square. So we cannot be able to find any integer value of n, that is value of n is always a non-rational, that is non-integer. So we cannot be able to find any integer value of n from this equation. So from these two sets of equation, we are not able to find any integer value of n, and consequently we cannot be able to find any integer value of m. We can write from these two sets of equation, from the two sets of equation, m minus n is equal to 1, m square plus mn plus n square is equal to 21, and m minus n is equal to 3, m square plus mn plus n square is equal to 7. We cannot be able to find any integer value of m and n. We cannot be able to find any integer value of m and n from these two sets of equation. So there are no positive integer pairs satisfying this equation. So there are no positive integer pairs satisfying the equation m cube minus n cube is equal to 21. So, there are no solutions, no positive integer solution of mn for this equation m cube minus n cube is equal to 21.